Hello my dear students, I warmly welcome you to SIA's digital classes. In this lecture, we are going to discussing about one of the elementary properties of the group, that is, there is only one unique identity element. Okay, so let's see the statement of the theorem. State and prove uniqueness of the identity in a group G. Or else statement, in a group G, there is only one identity element. Okay, so if you take every group of integers, group of real numbers, okay, group of complex numbers, group of integers, whatever it may be, if you take any group with respect to addition modulo, multiplication modulo, okay, so there exists a unique identity element. Okay, that is only we are going to prove now. So see, given capital G is a group, capital G is a group. Now I am writing claim. Claim is nothing but what we have to prove. Okay, so identity element identity element is unique. Identity element is unique. This we are going to prove now. Okay, to prove that condition, now I am suppose E dash and E are two identity elements in a group capital G. Okay, so we have to prove in a group capital G there is only one identity element. To prove that condition, I am taking two identity elements, that is E dash and E. Okay, so now according to the definition of the identity property, I am writing here for E dash. Okay, first of all, if you take E dash is an identity element, according to the definition, we can write A into E dash is equal to E dash into A is equal to A, where for all small a belongs to capital G. It is taken as equation number 1 according to the identity property only. And again we have another identity element small e. Okay, so for that a into small e is equal to E into A is equal to small a. This is I am taking equation number 2 for all small a belongs to capital G. For E dash we have equation number 1 and small e we have equation number 2. Now substitute small a is equal to E in equation number 1. Substitute small a is equal to E in equation number 1. Then E into E dash is equal to E dash into E is equal to small e. Okay, so you can take equation number 3. Again substitute small a is equal to E dash. Small a is equal to E dash in equation number 2. Then equation number 2 will become E dash into E is equal to E into E dash is equal to small e. That will become equation number 4. We got equation number 3 and equation number 4. Now you can compare both equation number 3 and equation number 4. Okay, here you have E into E dash, here you have E into E dash, here you have E dash into E, here you have E dash into E. Both are same only and equal symbol also there. Then we can equate these values also. Okay, so we can equate these values also. So therefore from that condition, from comparing of equation 3 and 4, okay, so we get that E dash is equal to small e. E dash is equal to small e. That is identity element are same. Identity elements are same. That is identity is unique. That is identity is unique. So that means at the starting of the theorem, we took that E dash and E are the different identity elements. At the end of the theorem, we got both are same. So therefore, if you take any group, in that group, there exists only one identity element in every group. So this is the uniqueness of the identity element in a group. Okay. So here you need to know that another thing is why we are choosing small e for identity. Small e for identity. The historical explanation gives that starting of the 19th century, okay, the German mathematicians were dominating in algebra. Okay, so the German word Einheit, E-I-N-H-E-I-T, Einheit meaning gives the meaning of identity. The German word Einheit gives the meaning of identity. That's why they are using small e as the symbolic representation. Okay, small e as the symbolic representation of identity. Okay, so that is the reason behind why we are using small e as the identity element. The German word. Okay, so German word Einheit is the German word. In that German word, identity is called as Einheit. So therefore we are denoting small e as the symbolic representation of identity. So this is the uniqueness and of the identity element. I hope you understood this theorem very well. In the next lecture, we are going to coming up with another elementary properties of the group. Thank you.